Good morning.
Morning.
Good morning.
Not many people yet here. I just wait about maybe 1-2 minutes and I will start. I can see that names here. People are little by little coming. I have some important announcements. So, and I will share with you. You know what, actually, I will read right now these names which I see here, just checking attendance. But you can think about possible questions which you like to ask me about. So today is 26th of March. I hope everything is well with you and your families. The following people should be here today. Bryce.
Here.
Gracia.
Here.
Alexia.
Here.
Stephanie. Hannah.
Here.
Andrew. Dimitar.
Here.
Benjamin. Cara. Jesus. Ariana.
Here.
Axel.
Here.
Desiree. Lila.
Here.
Bhaktima.
Here.
Jessica.
Here.
Ivuna.
Here.
Ivuna, I could not hear.
Here.
Okay.
Yeah. Mama,
David.
it's not that good.
David.
Here.
Valeria.
Here. Here.
Okay. A little bit later, I will check one more time, but now let me talk again. In just 1 second, please. In general, we try to follow our regular schedule. I'm not talking about my only class. I'm talking about college as a whole. We would like to follow our regular schedule, which we had at the beginning of semester and up to that day when we had last face-to-face class in our classrooms. So according to that schedule, tomorrow is a flex day. Unless you have special instructions from your teachers, you can observe that flex day. What is the meaning of that for students and for us? We actually should be available. We will be working. But for students, it means that regularly during flex days, they do not have classes. But because of special circumstances, some teachers maybe can ask you to have some classes. Again, I cannot be responsible for anyone. We do not have with you in your class any lecture on Friday because we meet on Tuesdays and Thursdays. This is why, again, or please email to your other teachers who actually had classes with on Fridays. But let me tell you about coming week. Coming week, it is our spring break. And if you look at your syllabus, you can see that we definitely will be observing this as a spring break. And I think, 1 second, please. I think it ends on April the 4th. I'm talking about spring break. Because I think the 6th of April is Monday. So 4th, 5th, so this entire week, it will be your break. Definitely, I will let you rest and I will not have any lectures during spring break. Is it clear to everyone?
Yes.
Yes.
But one thing what I need to talk about as well. We already covered chapter 2 completely, and we reviewed chapter 1. As I already talked about that, we have enough material to have a first test in this class. And I am planning to have this test practically right after that spring break. Please be serious about reviewing this material during that whole week, because you will not have classes, so you will have some time. I'm not saying do that 24 hours, forget about all other things, and just 24 hours a day review trigonometry. But please, at least at least 1 hour, 1.5 hours to review all formulas or values, because our first test will have material from first 2 chapters, chapter number 1 and chapter number 2. Unfortunately, I did not have an opportunity to send you back actually results of that quiz, but I will try to find some time today during our today's lecture to go over these problems which we had in our last quiz, because I graded this long time ago, but unfortunately I have these papers because I did not have an opportunity to pass it to you. And I will try to review today everything what you like to review from these 2 chapters. Is it clear for everyone?
Yes.
Yes.
Excellent. Dear ladies and gentlemen, what would you like to ask me about right now? I'm waiting for your questions. Would you like to maybe review some material? You have some kind of preferences, or you let me choose?
You can choose.
You can choose.
Okay. In this case, I really recommend you to go to the chapter review for chapter 2 right now. Chapter review is a good source to review. Why? Because it has all typical problems and formulas also. If you look, for example, at page number 172, this is where chapter review starts. On page 173, on page 174, and page number 175, you see in the concentrated form all actually topics which were covered in chapter 2, which is very good. At the same time, in chapter review, we have review exercises as well. Review exercises, they start on page 176 and they are being continued on page 177. These are very good arrangement of that review material. And even on chapter 178, you have so-called chapter test on 178 and being continued actually on page 179, because you have here chapter test, you have here cumulative review. This is what I like about this book, textbook, because I think chapter reviews here are being presented in very nice way. So on page 173, I hope you can look at that page. You can see table of values. These are table of values for many important actually angles, like 0 radians or 0 degrees, pi over 6 or 30 degrees, pi over 4 or 45 in degrees, pi over 3 or 60 degrees, pi over 2 and 90 degrees, pi and 180 degrees, 3 pi over 2 to 70 degrees. In other words, these are values which we covered. We call them values of quadrantal angles and reference angles. So they're right here on page 173. We have graphs of functions on page 174. We have objectives and references in terms of actually, you know what, references in form of pages numbers and etc. This what I'm going to do. I'm going to ask you that question. Would you like to work with me right now, mainly working with these problems from review exercises page? Or you like to go back choosing certain problems from old material?
Review exercises.
Review exercises? Okay. In this case, can you please be on chapter review on page 176? And right now, we will try to have 1 or 2 problems from each spot. I'm starting right from the top. It says, in problems 1 through 4, convert each angle in degrees to radians. Express your answer as a multiple of pi. So we covered this material quite a long time ago, and it will be really nice to review because it was, I think, material from 2.1. Let me grab scratch paper and let me show you something. I hope everyone can see that this was our last problem last time, right? Guys?
Yes.
Okay, just to remind you. And I'm going to start solving problem, let's say number 4. Number 4. Page 176. In number 4, we have 15 degrees. Okay, so we have our angle shown in degrees measure. Definitely, I can show this right away, and there are so many different ways to solve these problems. Well, one of the extremely easy ways, because it is 15 degrees, is it half of 30 degrees?
Yes. Yeah.
We know that for 30 degrees, equivalent in radians is pi over 6. Basically, it is 1/2 of pi over 6. It is pi over 12. But this is not typical. It is like very shortcut for this particular actually measure, 15 degrees. But not all the time it will be just 15 degrees. Maybe it can be 13 degrees or 17 degrees or 29 degrees. In this case, we cannot use that shortcut. We need to have the traditional way to solve the problem. This why I would like to remind you important sentence which I told you to memorize forever, because if you forgot certain formula, how to convert angles from degrees to radians or from radians into degrees, you can easily use it to remind yourself what to do. What kind of phrase I'm talking about? This is that actually magic connection between pi and 180. Is it true that pi, which means pi radians, equal to 180 degrees?
Yeah. Yeah.
We talked about all the time. So if you need to have representation of, let's say, 1 radian in degrees, so what should you do? You need to treat this pi like pi times pi as a number, this time pi times 1 radian. So if you need to find representation or formula for 1 radian, so it will be 180 over pi. Don't forget to use degree sign. 1 radian is equal to 180 over pi with degrees. So this, if you had originally your angle in radians, and you need to convert this into degrees. Second, so this is like part 1. Second, use the same sentence to convert degrees into radians as we are asked in this problem number 4. What can you do here? This time you can think about 180 degrees as 180 as a number times 1 degree. To find formula for 1 degree, you can treat 180 like a coefficient of 1 degree, and you can divide both sides by 180. In this case, 1 degree will be equal to pi over 180. Definitely this is in radians. It is up to you to write abbreviation in radians or not. You can see we are using same formula that pi is equal to 180 degrees, and we can get both new formulas out of this one. One, for formula number 1, helps us to convert radians into degrees. The second one will help us to convert degrees into radians. Let me show you right now, again, this traditional way for this particular problem. We already did it using the shortcut because 15 degrees was very attractive. It had very close relationship with 30 degrees as a half of 30. But how would I do that? Using traditional way. Look what I'm going to write down first. That 15 degrees, can we write that it is 15 times 1 degree?
Yes.
Now, instead of 1 degree, I'm going to use what I had in that formula number 2, which we had right here. So which means it will be pi over 180. And now let's see if we can cancel 15 and 180, or you can multiply and cancel later. I prefer to cancel before I actually multiply. Let's see if 180 is divisible by 15. I know the answer, definitely it will be. But let's use our calculators, let's say, to prove it. So I entered 100. Can you see, guys?
Yes.
Yes.
So I would cross 15 and write 1 next to that on the top. I will cross 180, I will write 12. This is how I did that. Canceled. And now I am proceeding. So it is pi over 12. Because they asked us to find this like a multiple of pi. And this is my answer. Using this way, you can convert any measure given in degrees into radians. If it is attractive, like 15 degrees, you can use this method. If it is unattractive, like let's say 122, let's say, degrees. So in this case, it will be 122 times 1 degree. Again, replace 1 degree by what it is equal to in radians and proceed. So this is a universal way. But definitely, I like to write the shortcut as well, because if you have in your problem really attractive degrees, like 15 degrees, like let's say 75 degrees, we can do that like 15 degrees times 5, if we already know 15 degrees. We can do that like 60 degrees plus 15 degrees. There are so many different versions. But at the same time, if we have 75 degrees, we can use that traditional general way to solve this problem also. But this time, what I'm showing, I'm writing that. I will show it right now on the screen. This is second method, and second method, I'm using the shortcut which we just talked about. You can see I wrote here, because again, second method is not a universal method. You can use it only if you have attractive measures. If you do not have such attractive measures, which can be multiples of reference numbers or quadrantal angles, use first method. Was I able to remind you what to do if you've that kind of problems?
Yes.
Yes.
Do you prefer right now one way or the other way? And I'm announcing first, I can solve another problem from 1 through 3 because this was number 4, or I can move to the next spot from 5 to 8. What do you like?
Too many problems.
Excuse me? For the next spot?
For the next part.
Okay. In the next part, problems, there are just few problems from 5 to 8. And now we need to do slightly different thing. In problems 5 through 8, convert each angle in radians to degrees. So a radian measure will be given. We need to convert this into degrees. Please choose your problem from 5 through 8.
7.
7, okay, 7. Oh, I would like to ask you something what actually disappointed me a lot. There is some kind of glitch in that Zoom application, and yesterday I had a lecture with pre-calculus class, and so far, even by now, I did not get a recorded video of that lecture. So I am going to report this problem today, but maybe they will fix it in quite timely manner. If not, I really like to ask everyone to have very detailed notes, because definitely as soon as I see availability of that recordings, I will definitely send you that link via email. But if I did not send you anything, which means that recorded videos were not available for me, please try to be patient. I will try to do my best to resolve that problem, okay? So this is what we have. Negative pi over 2. Again, I will show 2 different ways. Please don't skip that minus. How can I write it down? Can I say that it is negative 5 pi over 2 as a number times 1 radian? Right? Because multiplication by 1 will not change this number visually, right?
Right.
Now, replace that 1 radian by this formula, which we had right here, number 1. So it will be negative 5 pi over 2. Don't forget, please, to use symbol of the degree, because if you accidentally forget that symbol, it means it is in radians. we need to multiply two fractions. Can you see that on the top and on the bottom you have pi's in multiplication, right?
Yes.
Cross them out. We can cancel them right away. So both pi's disappeared. But at the same time, can you see in the first part here we have 2 in denominator. In the second fraction we have 180 in the numerator. Can we cancel by 2?
Yeah.
So let's do that. Cross that 2, cross that 180, and proceed to the answer. You can see what we have. Now, we had 2 fractions. Now we have from the first fraction only -5. From the second we have 90. Can we multiply them? Definitely. Don't forget about minus. 5 times 90, is it 450 degrees?
Yeah.
Yes.
This is your answer. So 450 degrees. This is again quite long but traditional way to solve these problems. Now, is it possible here for this particular problem to use shortcut method? Oh yes, why? Negative pi over 2. Is it negative pi, negative 5 multiplied by pi over 2? Can you see?
Yeah.
Yes.
Do we know that for pi over 2 in radians, equivalent is 90 degrees?
Yeah.
So just multiply -5 now again by 90 degrees and you have this answer.
Okay.
Definitely not every single problem could be solved in that way. If, let's say, instead of -5 pi over 2, I had -5 pi, let's say, over 7, I could use only first method. But if I had -5 pi over 4, -5 pi over 3, over -5 pi over 6, I definitely easily could use second method as well. Do you have questions about these 2 first problems?
No?
Are you satisfied?
Yeah.
With your permission, can I move to the bigger spot? And the bigger spot here runs from problem number 9 to problem number 30.
Okay. Yep.
And I will try to solve not only one problem from this big spot. I can accept your ideas which one to solve. I definitely will try to accommodate your requests. Can you please critically look at first 2 lines, which means from 9 to 14 so far, and choose your problem.
Number 13.
I cannot hear.
13.
13? Okay, number 13. I'm going to read what it tells us to do. In problems 9 through 30, find the exact value of each expression. Be careful with that. It says exact value, which means you need to recall formulas and values which we covered. Second phrase, he states, do not use a calculator. So what do we have in problem number 13? We have 6 cosine 3 pi over 4 plus 2 tangent negative pi over 3. 6 cosine of 3 pi over 4 plus 2 tangents of negative pi over 3. Let's talk. First of all, look at this first angle. Is it 3 pi over 4?
Yes.
We do not have this listed between reference angles or quadrantal angles, right?
Mhm.
So which means we need to choose certain way how to convert this first expression into something more attractive for us. Second, can you look at the second angle? Can you see the angle is negative pi over 3?
Yes.
Yeah.
And we also do not have negative pi over 3 angles in our tables of values. So which means also we need to do something with that particular angle. Let's start. The first expression, which I am going to work with here, will be cosine of 3 pi over 4. But definitely I will start with this 6, and I will critically think about 3 pi over 4. If you feel more comfortable with degrees, you can even, in your mind, you don't need to do that on the paper, but in your mind, you can try to convert this to see the location of that angle, because we have 4 different quadrants: number 1, number 2, number 3, and number 4. 3 pi over 4. Pi over 4, is it equivalent of 45 degrees?
Yes.
Yes.
If you multiply by 3, 45 times 3, what do you get? Is
1.
it 135 degrees? Guys,
Yeah.
can you more actively please participate? Now, in other words, 135 degrees, or its equivalent in radians, 3 pi over 4, is located in the first quadrant, second quadrant, or the third or fourth.
Second
Is
quadrant.
it
Okay.
absolutely correct? Is it between 90 degrees and 180?
Yeah.
Yeah.
Now, let's think how we can present that 135 degrees. Can I say that it is actually 90 degrees plus
45.
45
Yeah.
degrees? From the other hand, can I say that it is 180 degrees minus 45 degrees?
Yeah.
You don't need to use both. You need to choose or. Which one would you like to have?
Plus.
90 degrees plus angle or 80 minus angle?
90 degrees plus.
Plus.
90 plus. Okay. So do that in radians. So it will be cosine. What is the presentation for 90 degrees in radians? Is it pi over 2?
Yep.
Is it pi over 2, which is 90 degrees, plus 45, which is pi over 4, right?
Yeah.
Can you see what I wrote? This, what I wrote, what we just discussed. Now, I am moving to the second part. We have plus 2 tangent of negative pi over 3. Tangents family, they have certain properties. Is it even or odd function?
Odd.
If it is the odd function, what can I do with this minus? We just last lecture talked about that a lot.
You place it in front.
Absolutely, yes. So you are grabbing this minus, taking this out of parentheses, and moving all the way to the front, right?
Yes.
If you do that, what happens with this minus, which we had in front of 2? Should we convert this into minus now?
Yes.
So write it down. So you took care of that minus, and now you have much more attractive situation, because actually now under tangent symbol, we have pi over 3, and pi over 3 is a reference angle. Now, I need to recall one property which we talked a lot. It was not in your textbooks, but actually I taught you that. Can you raise your arm and hand, right, like that, and look at parentheses which you have next to cosine? It is pi over 2 plus pi over 4. Pi over 2, is it a quadrantal angle?
No.
Pi over 2, which is 90 degrees. Is it a quadrantal angle?
Oh, yes.
Yes.
Quadrantal angles are formed by x and y axis. Yes. Is it vertical quadrantal?
It's vertical.
Yes.
If we have in that kind of parenthesis vertical quadrantals, do we keep the same function or we need to switch to cofunction?
Chained.
Which,
Absolutely yes. So practically we will be changing cosine to sine. Second, in the second quadrant, we just talked about that this pi over 4, 3 pi over 4 or 135 degrees, it was from the second quadrant. In the second quadrant, cosine is positive or negative. Don't forget,
negative.
cosine is affiliated with x coordinates. So what is the sign?
Negative.
So put everything together. So which means instead of cosine, we will be having negative sine of reference angle. So which makes everything much easier. So it will be minus sine of pi over 4 minus, because it is the second quadrant, and it was switched to sine because in parentheses we had pi over 2, which was one of vertical quadrantal angles. Now, I am moving to the second part, -2. But here, dear ladies and gentlemen, you need to tell me about the value of tangent of pi over 3, because tangent of pi over 3 was in your charts. I am waiting.
Root 3.
Excuse me, square
Root of 3.
Yeah, it is square root of 3. So, which means just replace that tangent of pi over 3 by square root of 3. Excellent. And now you have to take care of that negative sign, but please help me with the value of sine of pi over 4. So -6, what is the value of sine of pi over 4?
Square root 2 over 2.
Yes, but you need to know this much better. You need to review all these values, guys. So drop parentheses around square root of 3. This is what you get now. And the one thing what you need to do, can you see that -6 and downstairs that 2? Cancel by 2. So I canceled by 2. You can see I crossed them out, and now I'm proceeding to the last answer. So it will be -3 times square root of 2, which is -3 square root of 2, and minus 2 square root of 3, and box it, because this is your final answer. This is exact answer. You don't need to approximate anything. Did you have an opportunity to write it down?
Yeah.
Yeah.
Can I remove it?
Yeah.
Guys, is it everyone's opinion?
Yes, ma'am.
Yes.
Okay. I'm ready to answer all your questions related to this problem. Was it clear? I'm talking about every single step.
Yes.
Is it clear just for one person?
Yes.
I have a question.
Yeah.
So when we started off with 6 cosine in parentheses 90 degrees plus 45 degrees,
Uh-huh.
I understand that because of the 90 degrees, you switched it to side.
The
But why did
rule states, if in your new form for that old angle, you are using vertical quadrantal.
Oh no, I get that part. It's just that how did we get from positive 45 degrees to negative 45 degrees?
Well, I'm not getting negative pi over 4 degrees or positive 45. No, I am talking about positive or negative for the cosine in the second quadrant, because original angle 3 pi over 4 or 135 degrees, we discussed that it was from the second quadrant. In the second quadrant, for any angle, cosine is negative. This where this negative sign is coming from.
Okay.
If
Okay.
I had angle, let's say from the fourth quadrant, it will be positive. Cosine in the fourth quadrant is positive. This why when you are using new form in parentheses for the old angle, you need to think about two important things: about the location of the old angle, which tells you which sign to use for this particular function, because all these 6 functions, they have their special sign, positive or negative, in each quadrant. Second question, which is extremely important, is what you have in this parenthesis. If you have vertical quadrantal angles, you will be switching to another function. If you have horizontal quadrantal angles, you will be keeping the same name. Do you feel a little bit better?
Yes, I do.
Excellent. I will let you choose from 2 other lines, from 15 to number 20. Choose your problem. Guys, would you like to do 19, for example? Because it has degrees, because in the first problem we used radians. I don't mind that. Choose yours.
19 is okay.
Okay, 19. It grabbed my attention because it had degrees. Because in all others, no, actually 20 also has degrees. But again, you are welcome to choose your own problems. Cosine of 540 degrees minus tangent negative 405 degrees. This is the problem. Cosine of 540 degrees minus tangent of negative 405 degrees, 405 degrees. First of all, what I see here, none of these angles we had in our charts of values. What can I do? I will simplify. 540 degrees. Is it more than 1 revolution?
Yes.
Do you understand that cosine is 2 pi periodic function, regular cosine? So which means you easily, without any hesitation, you can drop 360 degrees out of 540 degrees. What is left?
180
Mm-hmm.
degrees.
Because 540, but is it 180?
Yeah.
Yes, because 300 minus, it will be 240 degrees, right? 240 degrees minus 60, it is exactly 180 degrees. Accepted. But I'm really unsatisfied with this minus, which I have in parentheses next to, in the second part. What would you do with this minus?
Positive to the front.
Absolutely, but can you see in front we had another minus? What should I do with that?
Maybe
I
positive.
need to addition.
Right, because it is minus negative, it is positive. So now it is tangent of 405 positive degrees. I'm showing this step by step what I do. But now, again, I say, oh, that here, actually, we have 405 degrees. It is also exceeds 1 revolution, right? Now, I'm ready to take the next step. Look what I did. Please continue using equal signs if you continue each time with new step. What about value of cosine of 180 degrees? 180 degrees is the quadrantal angle, which ends second quadrant and starts the third quadrant. What is the value of cosine?
-1.
Accepted, -1. Now, ladies and gentlemen, what would you do with 405 degrees? Can you do same thing what we did with 540 degrees?
360 plus 45.
Not only, this is tangent. With tangent, we can drop all multiples of 180 because tangent, general tangent, basic tangent, and cotangent, they are pi periodic. 2 functions are pi periodic. 4 functions are 2 pi periodic. So which means from cosine, sine, secants, and cosecants, you can drop multiples of 360 degrees. You can drop 360, you can drop 720, you can drop 1080, etc. If you have tangent or cotangent, you easily can drop 180 degrees, 360 degrees, 540 degrees, 720 degrees, etc. Because tangent and cotangent, basic tangent, cotangent, they are pi periodic. Pi is 180 degrees. This time we can drop 360. What is left?
45.
That's it. So which means tangent of 405 degrees or tangent of 45 degrees, they are equal. By the way, what is the value of tangent of 45 degrees?
1.
Excellent. So practically you have -1 plus 1. Do they cancel each other?
Yes.
And look what you have. You have 0. And this is your answer. Questions?
Can you repeat what you said about dubbing? So for tangent and cotangent, if there's a
For tangent and cotangent, if you like to simplify and your angles are exceeding 1 revolution, you can easily drop multiples of 180 degrees. Multiples of 180, which means you can drop 1 times 180, 2 times 180 degrees, 3 times 180, 4 times 180, 5 times 180, all multiples of 180 degrees. For 4 other functions, you can drop multiples of 360 degrees. Again, why? Because for basic functions like sine, cosine, secant, and cosecant, they are 2 pi periodic functions. Even their formulas for period are 2 pi over omega, if you remember. But for tangent and cotangent, formulas are pi over omega. They are pi periodic. Okay, I would like to ask you to choose problems from 2 next lines, from 21 to 26.
24.
Did you say 24?
Yeah.
Okay. Tangent of 10 degrees, cotangent tangent of 10 degrees times cotangent of 10 degrees. And 10 degrees is angle is quite small angle. By the way, is it in the first quadrant?
Yes.
So basically, I cannot drop here anything to simplify the angle because it is very small angle in the first quadrant. But you can recall some formulas or relationship between different trigonometric functions. Can you please name formulas which represent reciprocals of functions? Okay, for sine function, what is the reciprocal?
Cosecants.
Cosecants. For cosine,
Secants.
secants. For tangent,
Cotangent.
cotangent. Excellent. So which means here we have product of 2 reciprocals, right?
Yes.
Can you tell me what the reciprocal of 5 is?
1/5.
1/5. What is the reciprocal for 20?
120.
What is the reciprocal of 1/25?
25.
25. So which means we can easily convert one reciprocal using formula into another. What do you prefer to leave in this problem? Would you like to stay with tangent or cotangent?
Tangent.
Tangent. In this case, copy tangent, get rid of cotangent. How? Because we know that tangent and cotangent are reciprocals, I can easily write, instead of cotangent of 10 degrees, I can write 1 over tangent of 10 degrees. Because we just talked about that. For 25, it is 1 over 25. For 3, it is 1/3. If you have 2/5, reciprocal will be 5/2. Reversed version. And now, if you multiply tangent of 10 degrees by 1 over tangent of 10 degrees, can you cancel these tangents?
Yes.
What is left for the answer?
1.
1. So it was not too bad, right? I am declaring right now 5 minutes break, and after that it will be 11:10. I will continue. Is it okay with you?
Yes, fine.
Yes.
Excellent. Okay, I hope everyone is back. Are you?
Yes.
Yes.
And let's continue. And I will let you right now choose one problem from the last lines. Actually, last line. We are left with one line from 27 to 30. Which one would you like to see right now? 27, 28, 29, and 30. Which one?
27.
Okay, 27. Sine of negative 40 degrees over cosine of 50 degrees. Sine of negative 40 degrees over cosine of 50 degrees. First, I'm going to take care of that minus. What do you think about this minus? What can we do with this minus?
Move.
Place it in front.
Sine as a function, is it odd?
Yes.
Yes, definitely, we can take it out. But we still have some problems here. Why? Because we have different angles. We have 40 degrees angle, you have 50 degrees angle. And you have to do something to get rid of 40 degrees or 50 degrees, but you can do that legally only. Are they both from the first quadrant?
Yes.
Yes.
Is it true that if we like to work with 40 degrees, can I say that it is 90 degrees minus 50 degrees?
Yes.
If we like to work with 50 degrees angle, can I say it is 90 degrees minus 40 degrees?
Yeah.
Yes.
Which means they are complementary angles, because angles are complementary if their sum is equal to 90 degrees. So now you need to choose or 40 degrees to stay here in the problem or 50 degrees. Which one would you like to keep in the problem?
40 degrees.
40 degrees. In this case, you are keeping the top angle unchanged, but the bottom part, I'm going to convert into what we just talked about, 90 degrees minus 40 degrees. And I'm writing this down. Is it true that cosine of 50 degrees or cosine of parenthesis 90 degrees minus 40 degrees, they are equal?
Yeah.
It's the same thing. And now, what I'm going to do to start the next step, I will copy the top, unchanged, just copy. But let's think what we have on the bottom. 50 degrees, which we wrote down like 90 minus 40 degrees. Is it from the first quadrant?
Yes.
Yes.
In the first quadrant, cosine is positive or negative?
Negative.
Negative.
In the first quadrant, no way.
It's
All
positive.
Positive.
positive, so it is positive. Now, in this parenthesis, you have 90 degrees. Is it vertical quadrantal or horizontal?
Vertical.
With the vertical, should I
Vertical.
keep cosine or I need to change to sine?
Need to change.
Change.
Excellent. Yes, change it. So it will be sine of 40 degrees, because 40 degrees here is a reference angle. So now, can you see what you are getting? Oops, what you are getting? On the top, you have minus sine of 40 degrees. On the bottom, up to you to write this plus or not. I did it purposely to attract your attention. So if you divide negative 40 degrees by positive, negative sine of 40 degrees by positive sine of 40 degrees, what do you get?
-1.
-1, definitely, it is your answer. -1 is your answer. Questions?
Goodbye.
Okay. Actually, during that break, I looked at the names here on the side. They are here in quite small size, but I definitely can read names of people and took care of attendance. The only thing I will call, because I promised you some names. Okay. Benjamin. Kyra. That's it. I'm done with that. Attendance now. Now, I would like to do something different, and after that, I will come to these review problems. What I'm planning to do, I would like to say a few words about that last quiz which we had in the class. Can you do some comments? Can you take some notes and make some comments on your papers? So, again, now this will be problems, and these are problems from your test, which we had in our class, and I collected papers, and actually all papers are graded by me, but unfortunately, I did not have an opportunity to pass it to you because that Thursday's class was canceled in our college. So, first problem which you had, let me look again, it was list properties for and graph the following function. It was y equals to 4 sine of 2x. So what kind of properties? First, if I were you, I would mention, again, this was your function, 4 sine of 2x. What did you have here? A is 4, then amplitude was absolute value of 4, which is 4. I'm going to do that quite quickly, guys. Try to make notes really quickly. Omega was 2, which means period is 2 pi over omega, which is 2 pi over 2, which is pi. So these are first two properties. Next, domain. We need to talk about domain. Domain for all sign family is R, set of all real numbers. Range, because we do not have here any vertical shift, the range will be segment, or you can say closed interval from -4 to +4. And these are properties. These are properties of that function. Do you have questions?
No.
No.
Please don't be confused. That A which you have here, it is not an amplitude. Absolute value of A is amplitude. If we had here -4 sine of 2x, amplitude will be 4 again. Because again, amplitude is the absolute value for A. Please, this Y, when you are showing information about amplitude, don't write A. Just write abbreviation AMP or entire word amplitude. So, what about the graph? This is the graph of that function. Please look at this graph. It is a graph in 2 cycles. What you do, you are sketching lines, horizontal lines through 4 and -4, and you show pi and -pi. Actually, I have here even more because one cycle is right here. It starts right here and finishes right here. And the second actually is right here. So here I have 2.5 cycles. 2.5 cycles. You can see all points are labeled. And it is quite smooth wave without sharp vertices. Can I remove it?
Yeah.
Yeah.
So the next problem. The next problem was find a period and amplitudes, and in parentheses I wrote, if applicable, for the following functions. And one of first functions, just 1 second, I will write it down, it was second part here. In the second part, we had a, so function was y equals to 3/7 cosine of -3x. And let me write it down for part B. Second function, I will show it to you right now. Y equals cotangent of 5x. These were 2 functions. 3/7 cosine of -3x and cotangent of 5x. Let's start with part A. Can you see that minus inside of parentheses?
Yeah.
Yes.
Please simplify. Don't say that omega is negative. I already talked about that. You need to all the time have this omega equal to the positive number. By the way, is it cosine of -3x?
Yes.
Cosine is even function or odd?
Even.
Even.
What should we do with that minus?
Drop it.
Drop it.
Drop it. So now it will be new version of that function, 3/7 of cosine of +3x. +3x. And now write down values of a and omega. A, is it 3/7?
Yes.
Yeah.
Omega, is it 3?
Yeah.
Let's talk about amplitude first. If we talk about cosine family, do they have cosine family members? Do they have amplitude?
Yeah.
Yeah. Yes. So in this case, you are writing that amplitude equals absolute value of 3/7, which is 3/7. Voila, you answered question about amplitude. Omega is equal to 3, and you are looking for the period of that function. What is the formula? 2 pi over omega or pi over omega?
2 pi
pi.
over omega.
So 2 pi over omega, which is 2 pi over
3.
3. 2 pi over 3. That's it. You have 2 answers. Amplitude is 3/7. Period is 2 pi over 3. In some papers, I saw period equal to -2 pi. No, we do not use negative periods. Your periods all the time should be positive. Can I move to part B?
Yes.
Is it, Jessica, is it you?
Yep.
Only Jessica answered yes, or it is everyone?
Yes.
Okay. Part B. What do we see here? We see here cotangent. A value is what? What is the
One.
1? Omega is what?
5.
5. Write it down. Now, I asked you to find the periods and amplitudes. Let's start with the amplitude. What is the amplitude for cotangent?
Pi
There's
over
none.
omega.
There's none.
Oh, no.
Definitely. This was a tricky question because cotangents do not have amplitudes. Their graph runs forever between negative infinity, positive infinity. Yes, we have A. This is a good example to talk about. This to demonstrate that, yes, we have that A. We will have this A all the time, but not all the time we will be having amplitude. We can have amplitudes only for sine family members, cosine. That's it. So amplitude, none. No amplitude, none. Now, what about period? What is the formula for cotangent? Is it 2 pi over omega or pi over omega?
Pi
Pi
over omega.
Omega.
Definitely pi. This time not 2 pi. It is pi over omega. Is it pi over 5?
No.
Yeah.
Yeah, it is. And I'm done. Do you have questions about this?
No.
There was some confusion on some papers. This is why I decided to go over that quiz, trying to help you to understand how they should be solved correctly. With your permission, can I move back to the review exercises?
Yep.
Yes.
I am now moving to the next spot here. And it runs from number 31 to number 46. Can you please choose your own problem from first 3 lines from number 31 to number 39, please? From number 31 to number 39.
38.
38, okay. 38. Let me copy, and after that, I will show it to you. Cosine of theta equals negative 3/5. And it says theta, angle theta, in quadrant 3. I'm going to write this using our symbols, math symbols. Look how I wrote it down. Cosine theta equals negative 3/5. Theta belongs to third quadrant. Are you with me?
Yes.
Let's talk. So, quadrant is number 3. Is it true that in the third quadrant cosine is negative?
Yes.
Yes.
Which means it is clicking. It is logically clicking. So you need to check this all the time. Okay, what should we do here? I'm going to read. Find the exact value of each of the remaining trigonometric functions. Do we have here information about only one function?
Yes.
Which is cosine. How many are remaining? Are they 5?
Yeah.
Yeah.
Sine, tangent, cotangent, right?
Yep.
Secants and cosecants. Which of these 5 remaining can be found easily, absolutely, if we have cosine?
Yes.
Secant.
Absolutely correct. Why? Because it is the reciprocal for cosine. If I were you, I would start my search exactly with secants. And I can easily write it down. Don't forget to write theta. If you just write secants, not theta, it does not make any sense. Every function should be accompanied by the angle. Secants theta is it negative 5/3?
Yep.
So this is your first answer, 5/3. So we are done with the secants. Now 4 are remaining. Now, ladies and gentlemen, you need to use end properties and formulas. Do we have any easy looking formula which connects cosine theta and sine theta?
Is
Which is?
A squared plus B squared equals.
We do not say a squared plus b squared. We say sine squared theta
Okay.
plus cosine squared theta equals to what? 1. Write it down. Sine squared theta plus cosine squared theta equals 1. Plug, instead of cosine, plug what you have, negative 3/5 squared. So you have sine squared theta plus negative 3/5 in parentheses squared equals to 1. And treat this as you would treat regular algebraic equation. Instead of x, we have here sine theta, which is like x squared plus number squared equals to 1, and solve it for that unknown. What is the square of negative 3/5? Is it 9/25?
Yeah.
Yes.
We have additional student who barks.
Yeah, my dogs.
Excellent. You have very educated dog. Your dog is learning trigonometry. So this is what we have. Sine squared theta, don't forget theta please, plus 9/25 equal to 1. Are we solving for sine theta? Yes. Can we move 9/25 to the other side, changing its sign?
Yes.
Yeah.
Let's do that. Sine squared theta equals 1 minus 9/25. If you subtract 9/25 from 1, what do you get? 1. Is it 25 over 25?
16 over 25.
Right. This is 16/25. But you don't need sine squared. You need to have sine in the first power. Can we take square root from both sides?
Yes.
Yeah.
Please do that. Now be extra careful, because taking square root, you need to consider plus or minus. Now, don't forget, you had that piece of information about the quadrant. Is it theta from the third quadrant?
Yes.
In the third quadrant, sign is positive or negative?
Negative.
So it will be negative 4/5. So negative 4/5, and we found value of sine. Sine theta is negative 4/5. Be careful. because we need to remember about location of theta. Theta was from the third quadrant. We have how many remaining? 3, right?
3.
Can you see we are doing this little by little, revealing each time the value of additional function. If you already know that sine theta is negative 4/5, which one you can find easily?
Cosecants.
What would be the cosecant theta value?
Negative 5.
Negative 5/4.
Yes, I think I heard Bhaktima and Jessica. You are correct, guys. Please, everyone, be more active. I remember your voices. So, negative 5/4. This is another value found. How many are left? 2.
2.
Tangent, cotangent. Do we have any formula, let's say for tangent, in which we can use sine theta and cosine theta,
Yes.
which is?
Sine theta over cosine theta.
Is it a question or answer? Because intonation is a little bit funny.
Answer.
Answer. And yes, you are correct, because before you even said that, I already wrote it down. Tangent theta is the ratio of sine theta and cosine theta. Can we plug instead of sine and cosine their values and find the value of tangent?
Yep.
Yes. So on the top, we have negative 4/5, which is sine theta. On the bottom, we have negative 3/5. If you divide negative by negative, is it positive?
Yes.
Can I replace this like by 4/5 times 5/3? Yes?
Yeah.
Yeah.
Can we cancel both 5?
Yes.
What do you have now for the value of tangent?
4/3.
Negative
Voila.
3/4.
4/3. Yes. Did we find that value as well? What is left? 1. Is it cotangent?
Yep.
Should we use any formula? Yes, we have formula for cotangent, which is cosine theta over sine, or we can do that much easier.
Just flip it.
Is it reciprocal of tangent?
Yeah.
What would be the value of cotangent?
3/4 negative.
Accepted. It will be definitely 3/4 because it is the reciprocal of. Are we done with all problem?
Yeah.
Yes.
We are done with that problem. Honestly, we are done. Now I have not a lot of time left to the end of today's lecture, about 10 minutes. And this is why I'm asking you to choose one option or the other option. We recently worked with so many graphs. So problems from 47 to 45, from 63 to 78, it is all about graphs. What do you prefer? To solve problems with graphs or to solve problems from this type of spot? We just finished the problem, which you choose from this spot, number 38, because we have 3 other lines from 40 to 46. Choose one option or the other. I will not have time for both. Would you like to do something with the graph right now or solve problem similar to what we just did, problem number 38?
Solve problems.
Like 38?
Yeah.
Yeah.
Okay. In this case, can you look at this spot from number 40 to 46 and choose your problem?
Mm, 43.
43? Okay. 43. Secants theta is 3. 3 pi over 2 theta is between 3 pi over 2 and 2 pi. This one?
Yeah.
Excellent. Can you please look at this interval for theta? What is the meaning of that? Theta is greater than 3 pi over 2, but at the same time, less than 2 pi. If your theta is between 3 pi over 2, greater than 3 pi over 2, and less than 2 pi over 2, what is the quadrant for that theta?
4.
Write it down. That theta belongs to the fourth quadrant. And now we are going to work in the same manner. We have one value, which is secants. We need to find 5 remaining values. If you have secants, which one can be easily found without any problem?
Cosine.
Cosine.
Absolutely, yes. Cosine equals to what?
1/3.
1/3. Voila, we have cosine. Is it true that cosine and secants in the fourth quadrant are both positive?
No.
Yes, because they are both affiliated with x.
Oh, yeah.
X in the fourth quadrant is positive. So is it yes answer? Yes, because
Right.
your answers should logically click. If it is not clicking logically, something is wrong. Now, if you know already cosine, can you find sine quite easily? Do you remember we used formula sine squared theta plus cosine squared theta equals to 1?
Yeah.
Use same formula again. Sine squared theta plus cosine squared theta equals 1. You replace cosine by 1/3 and you will get another algebraic equation with respect to sine squared. This is what you have. Sine squared theta plus cosine squared theta equals to 1. So sine squared theta plus 1/3 squared equals to 1. Let's simplify. 1/3 squared, is it 1/9?
Yeah.
Yeah.
So write it down. So you have sine squared plus 1/9 equals to 1. Can we move 1/9 to the other side? Like minus 1/9.
Yeah.
If you subtract 1/9 from 1, which is 9/9, what do you get?
8/9.
8/9. So sine squared is equal to 8/9. But this is for sine squared. We don't need sine squared. Can we take square root from both sides?
Yeah.
Let's do that. Square root, square root. Now, be careful here again. You need to choose or plus or minus. In the fourth quadrant, side is positive or negative?
Positive.
Negative.
Guys,
Oh,
Negative.
Definitely. Sine, is it affiliated with y? Y coordinate in the
Yeah.
fourth quadrant is so negative. Now, square root of 8. 8, is it 4 times 2?
Yeah.
Guys,
Yes.
so because bottom is 9, square root of 9 is 3. So can I write this like square root of 4 times 2? Now square root of 4, is it 2?
Yes.
So it will be negative 2 square root of 2 over 3. This is your exact value. This is your exact value for sine theta. Did you copy?
Yes.
I really apologize. I'm a little bit in a hurry because I like to finish everything on time. So now, if you know value of sine, can you find cosecant's value?
Yes.
Just what? Rotate that. It will be negative for sure. 3 on the top, 2 square root of 2. But in math, we never leave answers like that having root in the denominator. What can I do? I can remove so-called irrationality from that. How? I'm going to multiply top and the bottom by square root of 2. Because if I multiply and divide by square root of 2, it is actually I'm multiplying by 1. But it lets me actually improve the situation. So it will be 3 square root of 2 on the top. On the bottom, I have 2 times square root of 2 squared. Square root of 2 squared isn't just 2.
Yes.
Yeah.
Do we have 2 also there? Is it 4?
Yep.
So, and now we have legally looking good answer. We have good looking answer. 3 square root of 2 over 4. Now, if I have values of sine and cosine, can I find tangent?
Yes.
So tangent is sine theta. Again, please be careful. Don't miss this theta symbol, which means tangent theta equals, what is the sine value? Negative 2 square root of 2 over 3. Cosine value, 1/3. Now, negative over positive, is it negative?
Yes. Yep.
And don't forget, it is the fourth quadrant. In the fourth quadrant, tangents are negative. So it will be negative sine 2 square root of 2 over 3 times 3 over 1. Can we cancel 3?
Yes.
So what is left? Negative 2 square root of 2. And this is your value for the tangent. We are left with one unknown, which is cotangent. But if I know the tangent value, I can easily find cotangent value. Is it negative 1 over 2 square root of 2? Yes?
Yes.
Can you see that we have an attractive square root of 2 downstairs?
Yep.
Let's do the same thing what we did before. Multiply top and the bottom by square root of 2. I do not have enough space here, so I will be writing this like a curve right here. I multiply top and the bottom by square root of 2. So, which means I'm going to continue. So it will be negative square root of 2 on the top. On the bottom, I have 2 times square root of 2 squared, right? Square root of 2 squared.
2.
Is it 2?
Yes.
But there is another 2 in front. Is it 4?
Equal 4.
I wrote this is like such a funny way, right here, turning. This is like here, right here, continuation like a curve. Can you see, guys?
Yeah.
Yep.
Just 1 second. My alarm clock is ringing, reminding me. Is it clear?
Yep.
And we are done with the problem. I exceeded time a little bit. We have 2 extra minutes, but I definitely do not regret that we finished the problem. I hope you also do not regret because it was for your benefits. How do you feel about today's lecture? Did it click? Was it normal, good review or not?
Yes.
Yes.
It was great.
Excuse me?
It was great.
So thank you for the compliment. But you did a good job also, but please be serious about reviewing all values because I really like to see everyone with good looking grade, okay? So again, I will see you after the break. Stay safe. And I wish not just to you, to all your families, just the best things. And again, I really, really hope that you can seriously review all these trigonometric formulas and values to succeed with coming tests. Can I finish that session with your permission?
Yes.
Okay, the warmest goodbye to everyone, guys.
Bye.
Bye. Have a nice, beautiful day.
Bye.
Bye, guys. Bye. Thank you for being during that lecture.